Hi, my name is BHarp, and for my legacy project, I chose to do my topic as stoichiometry. Stoichiometry is the numerical relationships between chemical amounts in a balanced chemical equation. An important thing to note is that you must always begin with a balanced equation. So when using stoichiometry, this would be the wrong equation, and this would be the correct equation. It also allows us to do many things like predicting the amount of products that will form, or it helps us determine the amount of reactants necessary to form a given amount of a product. You can use stoichiometry in finding the limiting reactant, the percent yield, titrations, the molar mass of gases, and it provides the theoretical yield. Another thing is how a diagram called the mole highway, which looks like this. But a more detailed version of this diagram would look like this. You can see how it shows that if you want to go from grams to moles, and then moles to moles, then moles to grams, that is the direction that you do it. Or if you don't have the moles yet, then you can take other directions as well. And so to recap, when doing stoichiometry, you usually want to use it based off the balanced equation. Stoichiometry allows us to predict the amount of products that will form and the amount of reactants necessary to form a given amount of a product. In stoichiometry, we can use it to find the limiting reactant, percent yield, titrations, molar mass of gases, and theoretical yield. And a great way to visualize on when trying to use stoichiometry to find these things is the mole highway. Okay, so now let's try some examples. So for our first example, we look at the chemical reaction Fe2O3 plus Al goes on to be Fe plus Al2O3. And so the question is asking us what masses of the two reactants are needed if you wanted to produce 23 grams of Fe. So the first thing that we should notice is how this equation up here is not balanced. So to fix that, we are going to write 2 right there, because now there are 2 Als and 2 Als over here. And then we're also going to write 2 Fe, so that there's 2 Fe's over here and 2 Fe's over here, which you can see is different right here. Okay, so now that we know all of that, and that we need 23 grams of Fe, and we need to find out how many of these two reactants need in order to get that much, we are going to have to calculate with 2 different stoichiometric equations for both of these individually. With that, to start off our first stoichiometry equation, we are going to write 23 grams of iron in front of both of them to start off these stoichiometry equations. We are going to write 23 grams of iron in front of both of them, because since we're going from grams to grams, and that is the amount of grams that we are given, that is what we are going to start with. And so, in order to get 23 grams, we are going to write 1 mole of iron over 55.85 grams of iron. And it is important to note that up here, where we have grams of Fe, it should always match the bottom part where it says grams of Fe down here. So in our next equation, since we have moles of Fe up here, we're going to have to have a fraction multiplied by it that has moles of Fe on the bottom, which results in our mole ratio. As you can see right here, because the mole of Fe2O3 is 1 over here, but for Fe, it is 2 moles as seen over here. So we can compare that by those two right there. And now we finish it off with the equation 159.69 grams of Fe2O3 over 1 mole of Fe2O3. And this is because it is representing that this many grams is in 1 mole of this amount on the periodic table. And so overall, we have gone from this amount of grams of Fe down to this, to its actual amount of grams. Then we did the mole-to-mole ratio, and then we went all the way over to the Fe2O3 grams of its actual one, and now we calculate for the answer, which is 32.88 grams of Fe2O3. And so now we do basically the exact same thing on the bottom, which, to save time, is 23 grams of Fe multiplied by 1 mole of Fe over 55.85 grams of Fe, which is then multiplied by 2 moles over 2 moles of Al and Fe, representing the mole ratio between these two 2's. And then finally, we have 26.98 grams of aluminum over 1 mole of aluminum, which results in 11.11 grams of aluminum. For example 2, the reaction below with 167 grams of Fe2O3 and 85.8 grams of CO produces 72.3 grams of Fe. And so the equation is provided there, which is Fe2O3 plus CO, which goes on to be Fe plus CO2. So we are supposed to determine which is the limiting reactant, Fe2O3 or CO. So we can start off by noticing how the reaction is not balanced. So the first thing we need to do is balance the reaction. We can start off by noticing how Fe has 2 on the reactant side, but 1 on the product side. So we're going to add 2 right there for the Fe. And then on the reactant side, it has 4 oxygen elements and 2 O's on the product side. So we're going to add 3 right here, a 3 right there, and a 3 right here to balance it out. Like in the previous example, we are going to use the provided grams of each of the reactants in our stoichiometric calculations. And like the last question again, there's going to be 2 different equations. So to start off, we are going to write 167 Fe2O3 grams and 85.8 CO grams. Starting with the top equation, we are going to cancel out the Fe2O3 grams with 1 mole of Fe2O3 over 159.69 grams of Fe2O3, which, as you can see, the 2 grams cancel out. Next, we will add 2 moles of Fe over 1 mole of Fe2O3, and then those two cancel out again. And then, as to see that we are looking for the moles of Fe, this is the end of our equation. So now we multiply them all up and we get 2.09 moles of Fe. Then onto the other equation, we have 85.8 grams of CO, and then like in the other equation, we are going to add 1 mole of CO over 28.01 grams of CO, and then, which goes on to be multiplied by 2 moles over 3 moles, which is the mole ratio, which then, after being multiplied, equals 2.04 moles of Fe. Now, when trying to find the limiting reactant, we know that is the lowest number with the lowest amount of moles, so that leaves us with 2.04. And yep, that's it. That's the end of our lesson. Thank you for listening, and I hope you learned a little bit about stoichiometry. Okay, bye.